Welcome back to Nut Top Design. My name is Jacob, and this is the channel where you will hopefully be watching me fail through going through different design systems. And today, before we get started with the topic of today's video, I'd just like to give a shout out to all you guys. Like, the support has been overwhelming for this first video. I would have never thought it would garner this many views. I was thinking, maybe 1 to 2, but holy cow, you guys blew it out of the water. And shout out to everyone that you see on screen. Truly genuine comments, honestly a part of the internet that I'm not well accustomed to. So I really appreciate the feedback. And for Yashkale9624, I'll be waiting. Well, wait no longer. Here is the video for you. So today's video, the assignment is going to be to design a URL shortener. And so kind of the format of how this series is going to go, I'm having Claude generate a design requirement doc like you see right here. And so I'm going to do my best to be able to implement this without doing any prior research or anything like that. So all the stuff that you see me failing and stumbling through is 100% real and a skill issue 100%. With that stated, then we have this bottom part. So after I do the initial design, there's going to be some curveball questions that he's going to throw at me afterwards. And hopefully after this video, I will then at a later date, hopefully later this week, put out another video of me actually addressing all the issues with my current design. And also feel free to comment all the problems that you see in the comments below. I'm looking forward to it. With that out of the way, what we're going to be doing today is, given a long URL, generate a unique short URL. So this is basically, I'm sure you've seen it before, bit.ly is famous for it. It's their entire business. You give them a long URL, perhaps in a subdomain, multiple slashes, parameters in, and it will give you a nice short URL. Very useful business application. And so given a long URL, generate a unique short URL. So that is the first step. All right, so given that first little prompt, I assume we're gonna have here a client, right? And it is going to interact with some type of a load balancer. How do I get this centered? Oh boy. Yeah, raw and unfiltered, you guys. All right, and then let's draw these arrows. So here to the load balancer, and then we're gonna shoot it out to a service because we are generating the URL. ID generation, and let's take a look at the requirements. So generate a unique short URL. So for a unique short URL, we could literally just generate, let's do some quick math here. So if we have 26 letters on the keyboard times 2, 52, and then adding all of the digits that we have 62. And so let's see how many different URLs we could get if we did like 62 to the 4, 14,000. So 62 to the 6th. 56 billion. If we ran into constraints with that, I feel like we would have a lot of money to be able to address those. So I guess we could do like ID gen, and then I guess base 62 encoded 6 digits. And the reason I feel like this is a good approach is it's short, right? Only 6 digits. It's letters and numbers, pretty memorable. And it would keep it really short for our initial burst. And it's also going to be unique, obviously, as well. All right, so then we're generating our ID, and then I guess, okay. So then we're obviously going to want to store it as well, right? So database. And then for the database, I'm feeling like a NoSQL would be just fine because, right, like maybe a DynamoDB of the world because it's just, a quick lookup, essentially like a map lookup, basically. And so we would write to it its ID and store in it its original URL, right? So, yep, that is the first portion of it. And then requirement number 2 is to, given a short URL, redirect the user to the original long URL. And so now it looks like we're going to have a different path from the load balancer, honestly, because it'll handle all of the business and routing logic as well. So we have like this read path. Let's see. And we'll just do like redirect API, and then this thing would just simply look it up in the database, and then if it does not, and then it'll get back something or not, and it'll redirect the person to where they need to go. And then in the redirect API, I guess you could also have some type of a validation to make sure that the format is correct and all those good things. And you could even have an exit failure, right? If you check if what was passed and the parameter was more than 6 digits, right? Or any invalid characters and things of that nature for quick exits. And then as well, I feel like Claude will probably ask me later, but this is perfect application for a simple cache. Right, and in my preparation for this video, I was looking at, what are types of things you need to look at, and it said to mention eviction policies, so probably like a least recently used cache would probably be fine for this initial design. So, right, so this service would, first check the cache, and if it finds it, we're golden. If not, we get the result back here and we write it out to the cache, right? Alrighty, so those are the first 2 functional requirements. All right, and so then for this third requirement, short URLs should expire after a configurable time period. So I believe that would literally just be inside of the database, right? You'd probably set like it's either time to live or time to die. I always forget. Like one of them is a James Bond film and the other one's the one that we want. Or they're both the same, who knows? And so we could have something, actually I'm not that, databases I'd have to say is one of my biggest weak points right now. I'd have to research this after the video. But either you could have something configured that triggers and will automatically remove it out of the cache as well, and the item inside of the database. But if that's not the case, then what we would want to do is have a column on this as well as like a created date as well as an expiration date. And then once we do the query, reading from it, we could just handle it on request, right? We get it back here, shoots back here, we get the item, we see that it's expired, and so we could write in here, delete it from the cache, if applicable, and return it. But honestly, it's probably fine just to leave it in the cache thinking about it out loud, because in that case, we would check the cache first, and the cache would ideally also have, the expiration information so we could determine it here as well. But the problem with that approach would be you could have a lot of stale or invalid ones clogging up valuable positions in the cache. So I mean, we could probably keep it in the cache, and then once we get it back, make sure we update the cache and delete it afterwards. So I feel like, yeah, that requirement is still encapsulated with these relationships. So fourth one, users can optionally provide a custom alias for their short URL. Okay, so that I feel like is also still encapsulated here because it would just be another request through the right one. I mean, which I guess we could show like this. So we have a right one, and it will either go through this path, right, if no ID was provided, else there could be some type of a verification or sanitize custom. And then it writes through to the database. And then obviously encapsulated in this as well is if it already exists in the database, then this thing would fail and the client would get notified about it. All right, so that's all the functional requirements. Now let's look at the non-functional ones. So very low latency on redirects. I feel like we achieve this currently by utilizing a cache. I feel like that fulfills that requirement. Very high availability. The system should never be down. So I mean, honestly, this could be achieved by horizontally scaling because all these would just be, instances of services deployed across multiple regions or whatnot. So I feel like that's pretty good. Short URLs should be unpredictable. Users shouldn't be able to guess other users' URLs. I guess I didn't talk about that, right? Because like, how would we get which thing we're trying to do? So I guess we would generate a number from randomly generate a number from 1 to 62 to the 6 would be. We'd randomly generate that, encode it, and then I guess that means we're missing an arrow here because then we would see if it exists in the database, and then if it doesn't, we come back here and we loop until we do get one. So the downside of that approach is that there will be retries, but since this system's mostly going to be read heavy, I feel like that's a fair trade-off to make. But the obvious benefit of this is someone can't just guess, and scrape all of the URLs that we have. The system should handle 1,000 URL creations per second and 10:1 read to write ratio. I feel like this is pretty good. Okay, so let's see if I've done my job according to Claude. So I guess I screwed up not talking about the functional requirements at the beginning. There we go. Things to improve on the next video. Design high-level architecture, yes. Talk through database choice, right? So we chose the NoSQL, just because it's a very quick object store that we're needing here. We're not doing any type of intensive queries or anything, so SQL is totally unneeded. My short code generation strategy, the base 62 using random ID numbers. Discuss caching strategy for reads. So we talked about that least recently used. So I guess it's, you could, let's say it holds about 150 or so, and I guess dumb again, right? No, never mind, sorry. So yeah, the read caching strategy least recently used. So based off of if it actually finds something or not, inside, if it doesn't find something in the cache, it will then go to the database, get it back, add that thing into the cache, and it'll evict whatever the least recently used item was in place of it. All right. And address how the system scales. It's set up to scale horizontally. But there would be very interesting discussions that I feel like I'm not prepared to make just yet about scaling horizontally, sharding the database, and things of that nature. All right, so curveballs, here we go. You chose NoSQL. What happens when a single database instance can no longer handle the right throughput? How do you shard? And what's your partition key? I feel like we would store the original ID, and since they're numbers, we could literally shard in ranges. And so inside of here in the redirect, the write path. And so we generate the ID, and then we would have some kind of a hashing algorithm to determine which database instance it needs to go to. A single URL just went mega viral, 50,000 requests per second for one short code. Your cache is handling it, but what happens when the cache node goes down? How do you prevent a thundering herd from crushing your database? Okay, interesting. So what happens when that cache node goes down? I guess this is food for thought for the next video. How to replicate caches. Interesting. I don't feel like I have a great answer for this one. So, yep, that's definitely for the upcoming video. Stay tuned. Your counter-based ID generation means short codes are sequential. A competitor is scraping every new URL you create by just incrementing the code. How do you stop them without sacrificing performance? I see. Okay. So right now I'm randomly generating an ID and encoding it. What I could do instead is just randomly gen base 62. So I'd randomly generate base 62, right? So in the space of A to Z 0 through 9. And so I could just randomly create up to 6 digits within this space, up to 6 digits total. And then that way it would be a lot less predictable rather than just going from number straight to the encoding. But I feel unsatisfied with that. I'm going to do some research because then again, it's like, well, if they figure out how we're encoding it, they could realistically just create something that churns through all possible combinations, which good on them if they're trying to do that, honestly. So I'm sure there's some type of a salt or cryptographic magic, probably using modulus, that can help solve this, but I'd have to look into that. So yeah, next one, how to replicate caches. How to guarantee unpredictable. Yep, and there's my spelling on full display. Unpredictable hashes. Okay. So a user creates a short URL and immediately shares it. The person who clicks it gets a 404 because the write hasn't propagated yet. How do you handle this consistency problem given your system favors availability? I mean, how do we handle this? Realistically, we shouldn't let the client know that it's been completed until it's actually been completed, and then just like, giving them a message like it may take up to 5 minutes or whatever for it to be available. Your system has been running for 3 years and you have 500 million expired URLs sitting in the database. Okay, they're never going to be accessed again. What do you do with them, and how does cleanup work without impacting live traffic? So, as I said, like we could probably just we could clean up as we go, like when we encounter. But then again, it's like if they're expired, are people going to be querying for them? So we probably need to have like some type of a cleanup cron. Cleanup cron that goes in and wipes out all of these things in the database on a certain cadence, maybe, daily, like in batches. Like it doesn't have to be, continuously updated. Because the data store is realistically going to be super small. I mean, we're talking about short URLs too. Well, the long URLs could be long, but still, it's not like we're storing movies or anything like that. Okay, well, those are the follow-ups. I mean, I guess there are a couple of questions that I need answered. Feel free to hop in the comments. What would you have done differently? What needs to be improved? Because there definitely do need things to be improved. And if you know the answers to the questions that I'm currently stumped on, please let me know. There is going to be a follow-up video to this, most likely this weekend, where I do those types of research questions, and we'll have better answers for how to shard, how to generate non-guessable short URL links. But in all, I feel like not super complicated. Thank you guys so much for watching. Again, I really appreciate the support on the first video. I look forward to growing with you guys. I hope you all have a wonderful rest of your days. Days, hopefully. Rest of your day, rest of your life too. Yeah, why not? And so, yeah, just one more quick reminder to subscribe before I get good, so you can fully laugh at and enjoy my current incompetence. So I appreciate all you guys for watching. Have a good one. See ya.